Hello, my name's Ken MacBeth. I have designed a new synth that I call the micromac. The micromac is a 3U Eurorack sized module for those with modular systems and would like to integrate it. The other version is to be a cased desktop synth with built-in MIDI um, casing, obviously, and a power pack. One or two people requested that if I make a demonstration like this, could it be done without reverberation? And I agree, I think that's a good idea. Although I like recording with reverb, people do want to hear what the thing sounds raw or clean or dry or whatever. So I have this small setup that I've made here, and what I'll do is I will show you the equipment that's going to be used as I demonstrate the unit. Okay, so what we have here, it's a standard MIDI keyboard unit. This is a Roland PC200. I think I've had this thing for, it feels like 15 to 20 years. But it's still a good keyboard for demonstrating this. Sometimes I use one of my Korg Prophecies, and in more recent days I've been using my ASR10 as a sequencer keyboard. Very useful it is as well. This unit here is known as a function generator. Now, this is a piece of lab test equipment which would probably be used by RF engineers. It can go as low as 0.1 hertz and as right up into megahertz. These things are great. They can be used as low frequency oscillators or even audio frequency oscillators for cross-modulative like effects. This unit features a sine wave, a triangular wave, and a square wave. I'm going to be having this hooked up to the micromac so we can see what external modulations might sound like. The small box here, this is the power supply unit. This is a 50 watt plus or minus 12 volt power supply capable of delivering up to 3 amps on the positive rail. It's a very powerful supply, but it makes the synthesizer extremely stable. I've actually got another one which is here, and this, I'll just tilt the camera a sec. Let me just do this. This power supply is capable of driving the 32 modules in my 5U system there. It's a great pack. It's not like a low power wall wart or something like that. It's ideal for this application. And here we have the micromac itself. I just wanted to show you this area here. For the 3U Eurorack modules, the unit will not be having MIDI. Obviously there's no case and there's no power pack either. On the rear of the unit is a 16-pin standard Doepfer connector, which will hook up happily to your Doepfer bus line or whatever other casing that you're using that uses that standard. Here we have MIDI in, and here we have MIDI through out. It can be toggled, I believe. The little unit at the back is the very sophisticated MIDI that John Canton Price has designed for this. It carries the salient features of the Pro Solo in a very compact area. So these things will be coming with the desktop version. So here we have the micromac front panel. This, as you may have gathered, is the prototype. The appearance is going to be the same for the 3U Eurorack module and the desktop version. Now, to go from left and right, or left to right on this, we'll start with this. This is the master tuning control. It'll shift the pitch generically from 0 to about plus or minus an octave. Below this we have the glide, that's analog glide. We have the white noise volume that's mixed into the filter path. These controls here are the frequency controls. On the original one that I took to NAMM off the micromac, I just had coarse controls on it. And they were okay, but I began to think it was just too fiddly to play with. So fine-tuning controls have been added here. Oscillators 1 and 2 feature 4 waveforms, that being sawtooth, square, triangle and sine. The third oscillator has 2 functions. It will work as a standard voltage controlled oscillator in the audio sense, but it also doubles up as a voltage controlled, if required, low frequency oscillator. It's got 6 waveforms. I've got an inverted saw on there, which is great for falling modulations, whereas the sawtooth is good for rising modulations. So I included both of these if it's going to be a controller. It's got the square wave, it's got the triangle, and it's got the sine. And this other noise, which is here, is pinkish, low frequency pinkish noise. It's great for modulation of the filter, especially when the filter is nearing resonant peak, or in fact at resonance. Gives a very splattery sound. Oscillator 3 has this switch here, which allows the master CV to be dislocated from it. And what I mean by that is it is then allowed to free run itself, which makes it a low frequency oscillator without speeding up or slowing down on the keyboard, unless you want that, because that can be good too. This here is a switch that I've called lower frequency for oscillator 3, and when that is switched on, oscillator 3 does go a heck of a lot slower than the other two. It goes quite low frequency. In cycles it's probably 0.5 Hertz, something like that. Next we have what would be considered the mixer. This is the volume control for oscillator 1, the volume control for oscillator 2, and this control here is the volume control for oscillator 3, but it also doubles as, say, a modulation volume. When oscillator 3 is cross-modulating the oscillators or the filter, this is the control you'll use to bring it in. These 2 switches here are the modulation switches. This switch here, when it's in the up position, oscillator 3 cross-modulates oscillators 1 and 2. This switch here allows the oscillator 3 to modulate the filter. So you can have modulate oscillators, modulate filter, or modulate them both, or none. And kind of while we're at it, this switch here, which I didn't explain, this is hard sync. Oscillator 2 can be hard sync to oscillator 1. Okay, next we have the filter section. This is a 24 decibel per octave transistor ladder filter, employing the 3046 chip and some discrete transistors. It's fed into a transconductant op-amp VCA. as the final output. This is your filter sweep from envelope 1. This is your resonance, and that's your frequency. Envelope 1 has a switch here. That switch is for polarity. So you can have an inverted envelope or a positive going envelope. This is the tracking. It's a dead center off switch. So when it's in the center, there's no tracking. When it's in the down position, it gives about 1 volt per octave. When it's in the up position, it gives about 1.5 volt per octave. And it's great because the filter closes down at this end and opens up at this end quite dramatically. This switch here takes the envelope for the filter and will allow it to sweep oscillator 2. And I did that because when you have oscillator 2 hard sync to oscillator 1, having an envelope sweep the thing is it's great for that sync sound. What we have here is the release switch. These are ADS envelopes, a dual ADS envelope generator with a switchable release. They're great envelopes, tight, punchy, snappy, and great to get them within an area this size. Let's look at the jacks along the bottom. We have master CV in and master gate in, and we can take the master CV out and the master gate out to drive other systems. I've included pulse width modulation in for oscillator 1, pulse width modulation in for oscillator 2. So they can move your squares in a pulse width modulation like way. You could apply fixed voltages to these connections, and you can change the shape of the pulse and leave it static. The next controls are this one. This is VCO1 CV in, VCO2 CV in, VCO3 CV in. So it's got, each oscillator has its own separate control voltage inputs, which is great if you're using, I use a Korg SQ10 3-track analog sequencer. You can have the oscillators all playing different tunes or sequency chord-like things, and you can use the master CV here with the keyboard to shift the pitch of your sequences. We've got an external audio in here, and that you can imagine will take in drum machines, CD players, record players, anything you like to stick in there. It has occurred to me that if you had a separate external oscillator, you could take the CV from here, drive the external oscillator, plug it into the external input, and then you could have a 4 oscillator sound. Okay. The next is each oscillator has its own output. So we have VCO1 out, VCO2 out, VCO3 out. And these are pre-mixer. These are the basic waveforms being derived from the pole of the switch there. Plugged in here, I've got that plugged into the function generator I mentioned. This is your VCF CV in, and you can control the filter frequency externally. There's a momentary switch here as well. That's a nice thing to have if you want to tap rhythms from the micromac. This is a prototype front panel, and this here, which says external audio, should actually say VCA CV, because the VCA envelope, or the output or loudness envelope, goes through this jack socket, then to the VCA. If you break that jack socket with another connection, your envelope here is disabled, but you can use something like a function generator, LFO, other envelopes from other systems, etc., to cause your loudness to happen externally controlled. And that's that. Now we should hear some sound. One of the things that we want to do here is give you an idea of what the oscillators sound like. I have the cutoff frequency on the filter wide open, no resonance, and the envelope is up, shall we say. This is oscillator 1 in the sawtooth mode. It's very low, goes out with the audio, and here's your fine tune. So that's the sawtooth waveform. That's the square waveform. Here's your triangle waveform. And here's the sine wave for oscillator 1. Okay. Yeah, it's low-endish. Alright, oscillator 2, it's going to sound much the same. That's your sawtooth waveform. Here's the square waveform. Triangle. Sine wave. So what I'm now going to do is I'm going to put these back to saws, and I'm going to mix them together a sec. Just using a little bit of modulation from the Canton there. But what I want to show is the sync function happening with oscillator 2. Let's go for that. And if we bring this down. So what I'm going to do now is flick this switch up, which is the envelope sweep for oscillator 2. Let's see what it does. We take that from the EG quite dramatic, quite a nice sound that. Next, I want to show what the pulse width modulation input does. We'll just focus on oscillator 1. So that's your square wave on oscillator 1, and now I'm going to plug in this waveform generator into it there. Here's your square. We're going to modulate it, the pulse width, with the triangle wave from here. Really thickens things up. Output this function generator, where I have it, is in fact quite strong, and if you saw some of the signal missing there, it's because the voltage coming out of it is too high. Check this out. This is the DC offset on this thing, and we should be able to make different pulse like sounds come from varying the voltage. So I'm not sending a waveform, I'm changing the voltage input. See what happens. So there you have it, a fixed thin pulse. That'll be your square right there, and then another thin pulse. An interesting thing to do would be to put it back to square, bring this up, maybe speed it up a bit. I'm bringing oscillator 2. Oh. I forgot that it's still on sync, but that's still quite nice. Quite like that. Let's take that envelope off oscillator 2 and take the sync off. That's quite a big sound, I'm sure you'll agree. Let's now see how oscillator 3 affects the control of oscillators 1 and 2 and the filter. I've got the sound there. What I'm now going to do is that switch there makes oscillator 3 modulate oscillators 1 and 2 via this, now what was a volume control, which is now a mod control. Listen. Slow this down. To put this lower switch on, and as you can hear, it will take some time to fall. Bring it up. Let's take the sine wave. Oscillator 3 is still connected to the main control voltage, but if we switch this off now, in fact, we were actually hearing oscillator 3 modulating but also being in the volume of the audio. Now it's out of the audio and it's also out of CV control, so let's see what this does now. Switch this into the filter, by the way. Let's see if we can do something with that. Bring in some resonance. Let's take the sweep oscillator 1, see what it does. To oscillator 2. Quite mad. Let's take this noise. Ooh, that's nice. This is the kind of pinky-like noise that I was talking about. It's quite mad. Take the oscillators out of that. Switch this back out. Yeah. Well, I've put the switches back to their down position, which is, yeah, if all the switches are down, the functions are basically off, apart from this one, which is the tracking, and that's on about the 1 volt per octave mark. I'd like to hear what this thing sounds like with all 3 oscillators in audio working together, and we'll bring the noise in. So let's see where we're at. Okay, let's bring this up. I'd like to put a bit of glide onto that. Let's see what it does. And I like noise, so bring some of that in. Resonance up just a little bit. Take the glide off. Excuse my playing skills. The Kenton unit that's sitting in here is set just now to multiple trigger, and I've asked John Price if he can also have a toggle for single trigger, so the notes don't trigger like that, and that's something that he's doing just now, so we'll have that. But it's a big sound. And I'll use some of the LFO that is sitting in here. Here's a little more percussive bass-like sound. Off a sec. Let's take this function generator again, and we'll plug it into the VCF input, see what it does. some of this, get rid of the generator there. Just a sec, and we're gonna take these down, open the filter up, and that's quite nice. No, it's not. Now that's the kind of sound I like to put into a bit of deep space reverb. But we'll keep it dry just now. Bit glide on should be nice. Long attack, see what it does. We'll switch the release off. It's quite nice. Let's bring this back down, do something percussive. Because the release is off, you can play in a very percussive way. That concludes my demo of this for just now. I'm sure that there are areas that I haven't covered. There's an infinite amount of sounds you can get from an analog synthesizer, as you know. It's kind of hard to choose exact things to play or demonstrate, but hopefully going around the front panel, hearing some of the sound are dry, will allow you to make your own mind up about the machine. I'm glad I'm making this project. It's going to be great having the two units. My dealers are very interested, so they're dotted about different parts of the world. Yep, if you want to get in touch with me, feel free. I'm still selling the micromac at the price that I first suggested on the web, on the forums and Facebook. Okay, well, that's that. It's been my pleasure to show you this stuff. Bye for now.